Hello everybody, this is the assignment 2 of the course Internet of Things. We are the group 17 and my name is Di Qingzhu. Our topic is about the architecture of the IoT. First, we need to mention the relationship between the architecture and the IoT systems. The IoT systems consist of the things which are constrained devices with limited memory, processing power, energy, and accessibilities. These things are connected through the IP-enabled constrained networks. The IoT systems are designed for different use cases with different extra-functional properties. The extra-functional properties are decided by the deployment view of the IoT systems. The deployment view mapping the IoT functionalities to the system physical elements, and the deployment and the different deployment views correspond to the IoT architectures. So it is important to understand the different IoT systems by looking into their architectures. Different IoT system architectures will have different deployment view. So, to understand the different architecture of IoT system, the most important is to know the different deployment view in the IoT system. According to latest literature, the IoT architecture deployment mainly consists of 3 function aspects. They are control deployment, device management deployment, and storage deployment. Each aspect of deployment can be classified 3 approaches depending on where the function is placed. Namely, they are cloud for function in cloud, fork for function in a fork device, and mist for function in end devices. The decision of where to place the control function affects the IoT system's extra-functional properties of latency, single point of failure, and the decision complexity. The decision of where to place the device management function will affect the system's latency, single point of failure, security, and scalability. Last, the decision of where to place the storage function will affect the system's extra functional properties of privacy, complexity of the decision, and scalabilities, latency, and the single point of failure. Now we will show some detailed deployment examples of some current IoT systems to help understand the different architectures and the deployments. First is the example of the cloud deployment, the Google Nest. As shown in the deployment view of the Nest uses both cloud and mist control, because the control function is both in the cloud and placed in the end devices. The control functions in end devices perform simple behavior, while the control functions in the cloud will perform more complex behaviors. A Nest implements a device management function in cloud. The data has to travel from the end devices to the cloud, while this will increase the latency of the system. A single point of failure exists because the failure of the user's internet connection or the failure of the cloud will lead to the failure of the control and the device management. NIST follows the cloud storage approach. All the historical data from the end devices are stored in the cloud storage. Then we come to the fork example. One kind of the fork deployment is called Docker. A Docker uses mixed control because the control function is placed in the end device called Docker client. Once the Docker image is built in the cloud, the image will store in the Docker Swarm, which acts as a gateway and is a kind of fork device. The Docker Swarm also has function of managing the end devices, so both device management and the storage of Docker follows the fork approach. Single point of failure exists because the failure of Docker Swarm will cause the failure of the device management and the failure of the storage. Because of the memory limitation of the fork device, the Docker cannot make the decision as complex as the cloud make. The last example is about the MIST approach. The Apple HomeKit is one IoT architecture which is mainly used this deployment approach. The HomeKit stores all data generated by devices in the user iOS devices. Then, the user iOS devices can also download the data from the Apple Cloud database. The personal and the device information is secured and protected inside the user iOS devices. A control function and the device management function are both placed locally in the user devices. After analyze different IoT system deployment examples, now we can compare different extra functional properties of fork, cloud, and MIST deployment approaches. The cloud approach will make the latency of the IoT system increase because the data has to travel through the internet and different constrained networks. The fork approach has lower latency because of the fork devices is closer to the end devices, while the MIST approach has the lowest latency because the data only needs to travel between the neighbors in the same constrained network. The further the data has to travel from the devices to the function, the higher the latency will be. Both cloud and fork approach introduce a single point of failure because the function is placed in a centralized or relatively centralized element. Contrarily, the MIST approach distributes the functions in different end devices, so there doesn't exist a single point of failure. Cloud approach do not have a good data privacy because data has to cross from the user managerial domain to the cloud managerial domain. Contrary to it, fork and MIST have better privacy as the data only stay in the user managerial domain. Cloud approach will decrease the security of the IoT system because the function is located in the cloud which is very easier to be attacked from the internet. The large device management functions and the large data stores in the cloud makes it become a very attractive target for the attacks. Contrary to the cloud, fog and mist are locating the function in the local network, so the security will be better compared to the cloud. Because of the high processing capacity and the high capacity storage, the cloud approach has a very good decision complexity, while the fog devices store less data and have less processing capacity, results in median decision complexity. The mist has not good decision complexity because of its lowest processing capacity and the lowest storage. Similarly, the highest storage capacity makes the cloud approach has very good scalabilities. This will result in more applications can be stored in the cloud. With the storage limitation, the scalability of the fog will not as good as the cloud, and the mist scalabilities will not be very good. Through the external functional properties comparison with the different deployment approaches, we can now get some conclusions. First, the cloud has large storage, high processing capacity, but higher latency. This makes the cloud fit for analyze non-real-time, long-period big data and deciding the complex behaviors of the devices, while the mist and the fog fit for executing the real-time tasks and analyze the local data because of their less storage and the less processing capacities, but the lower latency. To improve the extra functionalities of the IoT system, such as the latency and the scalabilities, one IoT system architecture can apply more than one deployment approach. For example, the NIST, which is mainly used the cloud approach, also applies the mist deployment approach in the control function. The different architectures will have different deployment and the different deployment approaches will lead to the different extra functional properties of the IoT system. So, when we want to design or choose appropriate IoT architectures for the IoT system, the most important things is to consider the use cases of the IoT system will do and what kind of extra functional properties of the system will have. This movie is mainly used the reference of the literature of Buck Harris' work, which is evaluation of Docker as edge computing platform, and the article of the Lelia, which is choosing your IoT programming framework, the architecture aspects. And also we use the reference of some Apple's official website and the documents from their website. That's all for the assignment 2 of our course IoT of the group 17. Thank you for watching.